Okay, hello and welcome to my channel. Today we're going to be solving problem 5, set 3 from MIT OCW course 805, Quantum Physics 2. Okay, so let's begin. This problem is pretty math heavy. Actually, it is just math. So, so problem A, you're going to consider U1, U2, and W are subspace of V. Okay, and you're given two things. V equal U1 direct sum W. V equal U2 direct sum of W. Your ask is U1 equal to U2. Are they the same? And proof. You're asked to give proof if yes. Okay, next is B. Prove that F infinity is an infinite dimensional vector space. F infinity is defined as x1, x2, x3, on and on. Okay. C, show that linear map T is injective if and only if null of T is only 0. Only contains the number 0. Okay. So let's begin with A. Okay, so this is pretty easy. You can just see that it is false right away. And to do this mathematically, you can consider and assume that V is two real bases, two real fields or whatever. Okay, so you have that V is equal to U1 direct sum W, V equal to U2 direct sum W as well. Okay, so an assumption here is that V is the combinations of two real fields. Now you can just say that suppose you have U1 is the x-plane, U2 is the y-plane, and W is the z-plane. So this satisfies that the direct sum of either U1 or U2 with W is going to give you the combination of two real fields, but they are not the same. Therefore, you can say that W direct sum U1 is not the same as W direct sum with U2. Okay, therefore false. So no need for further proof. Right, now let's move on to B. You're given F infinity is x1, x2, x3, and this goes on and on. So from here you would, construct a list of E1, E2, E3, all the way to En. And this list is gonna have the property of EI is gonna be equal to 0, 0, 0, 1, 0, 0, or something like this, where this is the ith position. So this would guarantee linear independence. So this linearly independent. Okay. So now we can just get it from here, but if you want it to be more mathematical, more rigorous, you can consider the sum from C1 E1, C2 E2, this is C, all the way to Cn En to equal to vector 0. Okay, and this would only happen if the list, if and only if here, so only if when the C1, C2, C3 way is equal to 0, 0, 0, all the way. So with this, when you shift it to the left or shift it to the right, it would be the same thing. So we're gonna get that this list up here is gotta be finite. Okay, so maybe E1, E2, E3 all the way to En has to be finite. No, finite length. So with finite length, meaning that there cannot be a list that spans f infinity, and that would means, so I will do it there. So no list span, no lists spans f infinity. Therefore, f infinity is infinite dimensional. Right, there we go. Next is problem C. Problem C, we're gonna show that t is injective if and only if null t is equal to 0. Okay, so we're gonna, this is the property for an injective linear map or operator. Those two are the same thing. So this would be the property of it. Okay, so let's just assume that our t is injective. And let small v to be a vector in null t. So this means that we have t of v and t of 0 to both be equal to 0. Therefore, this is injective, so 1 to 1, meaning v has to be equal to 0. And now we have both v is inside null t and v is equal to 0. We can say that null t only contains number 0. This is pretty simple. All right. And that will be it for today. Goodbye.